For most of human history, people have looked at the sun with a mixture of fear and fascination. It is a blazing sphere of fire so powerful that a single glance can blind us, a nuclear engine so intense that its light crosses 93 million miles of empty space to warm our skin. And yet, in the middle of all this unimaginable heat and light, there is a mystery that seems almost paradoxical. Why does the sun burn so fiercely, but the space around it remains cold and dark? Why does the solar fire not spill out and ignite the vacuum of the cosmos? Why does something so overwhelmingly hot exist inside something so overwhelmingly cold, as if the two were never meant to touch? To understand this strange coexistence, we need to dive into the true nature of heat, energy, matter, and the empty void that surrounds us. The first truth is one that feels counterintuitive. Space is not cold because it absorbs heat. Space is cold because it almost cannot absorb heat at all. Heat is the movement of molecules, the vibration of matter. In the vacuum of space, there are almost no molecules, nothing to vibrate, nothing to heat up. When you place something hot in air, the air around it warms through conduction and convection. But in space, there is no such air. A hot object does not share its warmth because there is nothing nearby capable of receiving it. This is why astronauts in sunlight face temperatures that can fry circuits, but in shadow their suits begin to freeze. Space does not behave like a cold room. It behaves like the absence of a room entirely. The sun, however, is not hot because it is on fire. Fire, as we know it on Earth, requires oxygen and fuel. The sun has neither. The sun shines because nuclear fusion in its core forces hydrogen atoms to merge into helium, releasing staggering amounts of energy. This energy travels outward through layers of plasma until it escapes into space as light and radiation. Plasma is not gas, nor is it liquid, nor is it solid. It is an electrically charged soup of particles that behaves like a fluid made of fire. Deep inside this churning sphere, temperatures reach 15 million degrees Celsius, far beyond anything flames could ever produce on Earth. The sun does not burn. It radiates. So if the sun radiates energy, why does space around it not become a bubble of boiling heat? Because radiation is not heat by itself. It is energy traveling through empty space. Only when this energy hits matter can it be transformed into heat. On Earth, sunlight warms oceans, rocks, and skin because these materials absorb photons and convert their energy into movement. In space, radiation simply passes by, untouched, because there is nothing there to capture it. The vast vacuum around the sun is like a desert with no sand, a sea with no water, an expanse where energy moves without resistance or interaction. Light spreads out, thins, and continues traveling until it eventually strikes something solid. Maybe a planet, a comet, a spacecraft, or nothing at all. But there is another reason space does not ignite. Fire requires chemical reactions. Space contains almost no chemicals. Without oxygen, flames cannot spread. There is nothing to burn, nothing to transform, nothing to fuel a chain reaction. Even if the sun released a wave of intense heat, it would find nothing to latch onto. Imagine throwing a burning piece of wood into a lake. The flame dies not because it stops being hot, but because it can no longer feed itself. In space, there is nothing comparable to wood or air. There is simply emptiness. Heat cannot cling to emptiness. As radiation leaves the sun, it weakens with distance. Light spreads out in every direction at once, like ripples in a pond. Near the surface of the sun, the energy is powerful enough to vaporize metal. But at Mercury's orbit, it becomes survivable with thick shielding. At Earth's orbit, sunlight is strong but not deadly. At Neptune's orbit, the sunlight is dim enough to resemble a cloudy winter afternoon. Just a few billion kilometers away from the sun, temperatures drop close to absolute zero. This extreme decrease happens because energy is no longer concentrated. It has dispersed, stretched thin across unimaginable distances. Yet the most surprising truth is this. Even near the sun, space is still cold. If you were in a spacecraft near the sun, your suit would only heat up where light strikes it directly. The unlit side of your body would freeze. The spacecraft itself would experience scorching heat on the side facing the sun and deep chill on the side facing away. Heat in space behaves like light. not like air. It touches only what it strikes. It spreads only through radiation. It does not fill the environment. It does not create a bubble of warmth. There is no medium for it to spread into. To understand how strange this really is, imagine holding your hand above a campfire. You feel warmth, not because the fire heats the air alone, but because hot air rises and carries heat toward your skin. In space, the sun cannot heat air because there is no air. The only warmth you feel comes directly from photons, traveling straight from the sun's surface to whatever they collide with. Space stays cold because cold is not a temperature, but the absence of temperature. It is the default state when nothing is present to absorb energy. This leads us to another fascinating realization. When we think of the sun, we imagine a blazing ball of fire suspended in empty darkness. But in reality, the sun is not surrounded by darkness. It is surrounded by its own energy. Space near the sun is filled with high-speed particles, streams of radiation, and solar wind. These phenomena are dangerous, even deadly, but they do not create heat the way air does. They shoot outward like invisible arrows, not like waves in water. They do not fill a space with warmth. They carry energy away. If the sun were placed inside a giant container filled with air, the space around it would indeed ignite and burn violently. But because it floats in a vacuum, it has nothing to transfer heat to. The sun can shine, but it cannot warm what does not exist. It can radiate, but it cannot ignite the void. The universe is mostly empty, and emptiness does not react. Emptiness does not glow. Emptiness does not burn. Yet despite all this, the sun shapes everything around it. Its light breathes life into Earth. Its energy drives weather, seasons, and climate. It warms oceans, fuels photosynthesis, and powers every ecosystem. Without the sun's distant heat, Earth would be a frozen rock drifting through a silent void. The sun's warmth is not distributed by space. It is delivered directly to the planets lucky enough to orbit within its reach. The sun does not heat the cosmos. It heats worlds. The universe remains cold, but planets come alive. Perhaps the greatest beauty in this paradox is what it reveals about our existence. Life thrives not because the sun burns everything around it, but because it shines precisely enough to warm a planet covered in oceans and atmosphere. Our world sits in the perfect balance, not too close to ignite, not too far to freeze. The sun's fire does not scorch the heavens. Instead, it travels quietly across emptiness, searching for the rare places where matter awaits, where energy can transform into warmth, into movement, into chemistry, into life itself. And so, the sun burns, and space remains cold. The two coexist in a harmony that allows planets to form, climates to flourish, and life to rise from silence. The universe may be dark, but within that darkness, one star sends just enough light to remind us how fragile, precious, and improbable warmth truly is.